Hello, I'm going to introduce year's monitor, and I'm a sophomore, Yu An Yang.
瑞斌杨
My name is Han Lu. I'm a sophomore.
My name is Xiyun Zhang. I'm freshman.
Freshman 戴很黄。
And now, I suddenly want to know how year's monitor works.
Okay, let's invite Heng Lu to explain temperature.
Temperature of the object in a small scale is energy spread by the molecules. In addition to send vibrations through molecular kinetic energy, electromagnetic waves was emitted by the molecules when it released energy. The famous of all is black body. Now, let us know what is black body.
The property of black body is that it will not reflect or transmit input energy and emit radiation of corresponding curve into the change of temperature.
Hey, you just talk with electromagnetic wave and radiation. Can you explain them?
Actually, electromagnetic wave is the same as radiation. But how can we explain the meaning of electromagnetic wave? No matter what kind of light is one of the electromagnetic waves with a higher frequency. They can be divided into several categories. Infrared, visible light, ultraviolet ray.
Hey, I'm interested about infrared. Can you say more about it?
Alright, let's invite Heng Lu.
Now, I'm going to introduce what is infrared. First, infrared can be divided into three categories: far infrared, mid-infrared, and near-infrared. Our lives are filled with a lot of applications of infrared. So, for example, optical communications, vision goggles, infrared-oriented missile, long-term communications, and fibers of the closest socks. Okay, these are samples about infrared. Now let's turn back to the subject of black body.
Okay, now let's go back to our learning. I am going to explain the relationship between electromagnetic waves and temperature. Scientists find that with a higher temperature, the higher frequency electromagnetic waves will be. So, if we have the higher temperature, we will emit more percentage of the blue rays. In contrast, if we have the lower temperature, we will emit more percentage of red rays.
I think a little bored. And there something interesting?
Alright, let me invite redshift. Another phenomenon of light is redshift and blue shift. When we have relative motion with light source, we will detect different frequency of the real one. For example, if we get closer to the light source, we get a higher frequency of the light. We call it as blue shift. If we move far from a light source, we get a lower frequency of the light. We call it red shift. See, interesting?
Actually, not.
What? What he say made me dizzy. Can someone come to take my temperature?
Now, I'm telling you how does ear thermometer work. Our ear has the similar structure of black body. Thus, we can use ear thermometer to measure the radiant which our brain emits.
Can you take my temperature now?
Oh, sure. Wow, 40 Celsius degrees. You are really fever now. You must get a rest.
Okay.
And can you tell me the difference between ear thermometer and normal ear thermometer?
Okay, the time taking is one of the difference between them. Normal thermograph has to balance the temperature with human body. However, ear thermometer only have to take the spectrum emitted by our body. That's why ear thermometer can take our temperature so quickly.
How about the forehead thermometer? It can take the spectrum too, right?
That's right. Spectrum can be taken from our whole body. However, since our forehead is open to surroundings, it varies with lots of things like inspiration compared to the forehead thermometer. Since our ear is similar to the body, we can take the temperature directly from our brain.
Now, we come to talk with you a good story. In 1929, Hubble discovered that there is redshift phenomena in the universe. That is, the distant universe are moving away from us, and the far away the universe is from us, the faster the universe are moving, which represents that the universe is expanding.
In 1964, Arnold Ponces and Robert Wilson received unknown radiation noise accidentally when testing the performance of home-shaped antenna, and they find the noise can be received in all directions. Shortly after, there are two other scientists measured energy value of the radiation is 2.7 K and named it as cosmic background radiation.
Based on the redshift phenomena and cosmic background radiation, the Big Bang theory gets strong evidence. So, called Big Bang theory is that universe was born from a tiny dot, and it suddenly exploded in the case of uneven distribution of energy spread. With time going, the universe unfolds, and cosmic background radiation is the temperature left then.
And it, Arnold Ponces and Robert Wilson, who found cosmic background radiation, as well as the other two who expanded the Big Bang Theory has won the Nobel Prize.
Now I'm going to introduce how to use the IR thermometer. First, we need to insert a 9-volt battery. You insert it and close the cover. Okay, now the screen is empty. And second, you pull the trigger, and then the machine is start to measure the temperature of the area in that red point. This red point is not IR source, but it can helps you aim the object that you want to measure. So you can see the temperature varies when the object changes. And these are some more its mode, like night light mode. You press this button and the lights turns on, so that you can observe the screen in a dark surroundings. And there is another mode, is turn off the laser point. You can continue measure the temperature if your laser point is turned off. It can help you measure a people's forehead, because the laser point may hurt one's eyes, so you can turn it off, and so it's more convenient to measure a man's forehead temperature. Okay, that's it.